We're at the Greene Farm Barn here in DuPage County, Illinois, April 6, 2012. We're going to do a little walk around and talk about the project as we start to wrap it up. Our aspect of it starts to wrap up and see if we can bring to light some of the topics that we believe could have been improved on early on in the game and caused a bunch of anxiety and a bunch of extra time and money because of when people don't listen to good advice, it's going to cost somebody money. And that's where we are today. A reasonable example of what we're talking about is the roof assembly that's going on in the background here. We're now starting to do the structural overhang amendment for the threshing barn area, granary and threshing barn area of this collection of barns. So what you're looking at today is our attempt to straighten out a crooked old building. Again, as undocumented as it was, something had to happen there, and nobody apparently asked what was going to be done until you actually get around to doing it, which is not inappropriate. It is hard to get an answer late in the game, though, about how to do these things sometimes, and that's what we found here. As we reached the gable end of the buildings, we came to an area that was completely undrawn and undocumented, and was for a while was argued that it didn't even exist, and that work didn't need to be performed because there was no reason to do it because it could just be left in place. Well, the contraindication there is also we were asked by the engineers to cut the material off, and by the architects to leave it in place, which is something you cannot do. We resolved the problem and developed the scenario, passed it through the appropriate channels. Took too long to get an answer, but we got an answer once they realized that it had to be done, and we went ahead and built it using engineer-approved systems and connections that we provided to make it possible. To do this sill repair in this corner, we have to grab a hold of that post and actually lift it up enough to be able to get new material in place. We're not going to try and change the elevation of it. We just have to hold it so we can do the work on it, to replace these rotten sill timbers. My concern is when we take the weight off of this area to do the sill work, that the wall will fall over. And I believe it's broken enough that if I'm not careful, it would. So instead of just being able to do the work, I have to now do the sill work. I now have to shore the wall up and hold the wall still, then pick the post up and the floor system up, then do the work, and then set it back down and take the shoring of the wall off. It's counterproductive. This whole area should just be rebuilt. The concrete block area should just be rebuilt. It's just it's an unfortunate circumstance that they don't believe this is important. As a builder, I believe it is. We're now looking at the inside face of the same corner that, where we're worried about the load path and the engineering resolution. What you see here is some temporary shoring in place, holding the floor joist while we try to resolve the load path and the actual solution to this area. We had originally asked this question in February, got no response, had not framed this section of floor while we waited for a response, still got no response, had to put the floor on, so we had to put temporary shoring in place so we'd be able to carry the floor and be able to work on ahead. It's kind of, it's been a little bit of an unnecessary loss of time for us. Just the momentum that goes with non-decisions is a big problem. We're looking for a resolution where we're ready to fix it as soon as they say go. So this whole timber from post to post is new. The siding is also new because it had rotted from the same area where the roof had leaked. Okay, and you know it's straightforward work. You can almost count on it being in place. but it was undocumented, but all of us that do this work for a living walked in here and said, there's going to be damage there. We're going to find some damage there, and there was. Again, at some point in the life of this barn, the timber came out of this mortise, picked up these posts, probably the full length of the original barn, which was another 24 feet down that way. In one of the remodeling processes, they removed that timber, and it's possible that timber went post to post to post. We don't know, but it's possible that these posts sat on top of that timber. When they take that timber out because they're changing the use of the barn, which is the most common reason to remodel, they had to stretch the posts out to reach the floor again, and they did this half-lap scarf with 4 bolts in it. Don't know if the engineer asked himself if that was him or herself, if that was the right thing to do, or whether they should do something about it. We haven't yet heard from them their decision about that. This particular location of this half-lap scarf, we wound up putting a structural member in there just for stability, because this particular post, which would be 1, 2, 3, 4, post 5, has had shown some inclination to lean over. And I don't know, the bottom of the post is where it was in the original building, because it was held in position as it was found. When Rick picked it up, it was held in position. But it's a combination of it's out of place from where it wants to be, and the load that was on the building as it was failing that Rick solved. It's a combination that allowed that piece to bend in the way that we're concerned about, because this is the possible failure mode for the whole series here, is if this one can go, what about the rest of them? And again, this is not supposed to be adversarial. This is supposed to be a teamwork project. Engineers have the knowledge, we have the experience. Let's work together to solve the problem. The one nice point about it, all the bolts were locally forged, so they're early pieces. They were made by a local blacksmith. We're still waiting for some steel fabrication to take place so we can take the temporary rigging off the building. We're hoping that it'll happen soon, but again, the issue is we've asked questions about the steel, we can't get answers about the steel, it stops everything. That's a problem to me. The roof on this whole section had to be replaced. Because the rafter feet, again, it's the same problem. The top plate and rafter feet collect water, dust, organic matter, and forms rot, and it took out the feet of 90% of the original rafters. So all the rafters in here are the original floor joists from this barn, resawn and reused in this new location. Evidence of that is the milk paint, the white paint that's on there from when it was in the dairy section of the barn, which would be below the floor we're standing on, at grade. These 4x8s right here are an engineered solution, making a composite beam out of the original material and some new material to bring it up to modern code. So you use new wood, glue, and a bunch of screws to do it. That's one way to build a composite beam. It's not the way that we might have chosen, but it was the engineers' experience level that caused them to do it. I asked them why they used those screws, and they said, well, we had the brochure on the desk and it really looked good. That's why there are other ways to accomplish the same thing that might not look like that. What we're looking at is the bottom of a sling brace and a post at wall A, post 2. And what we have is an engineered specified steel attachment just mocked up in wood, because we found a problem that made it impossible to assemble it. We have a side plate that will be in 3/8 inch steel. We have another side plate on this side, but we also have a large plate coming together from the other direction that doesn't allow this plate to be continuous. So we have to redesign. We've asked them to redesign a connection here that we can actually include all the pieces of steel that they want. Again, this is not fault finding. This is just the reality of if you don't build this stuff and you just draw it, and you don't draw it three-dimensional, you're going to make these mistakes. And we're all here. We're here to build something, not to argue about how to do it. But the fact is, if this had been modeled in 3D, which is tends to be how the modern draftsman's working today, but these folks did not, for whatever reason, we wind up with something that's not unbuildable, but it needs serious reconsideration to make it possible to build it and to do all the things that it wants to do. There will, of course, at this point be plenty of questions about, well, you've got all these fasteners in here, how do we actually install them? Because there's wood in the way. And the draftsperson looked at this as a two-dimensional challenge and never realized that I wouldn't be able to get a drill in here to do the work. And what happens to that piece of wood when I put all these holes in here? Doesn't look bad on paper, but it looks really bad right here. It's a learning experience for everybody, and it's just a reminder that building needs to be team-based, or it gets more complicated than it needs to be.